Hey, I'm going to walk through the final exam review for Chapter 1 for Algebra 2. Okay, let's write this slope-intercept form of the equation of the line shown here. So slope-intercept form is going to be y equals mx plus b. So the m is the slope, the b is going to be the y-intercept, okay? So hey, here is my y-intercept, so b is going to be -2. Okay, and then to get the slope, I'm going to just choose 2 points. It's easiest to choose 2 points that are kind of on the grid, like this point that I already have marked, and say this one. And then I'm going to do rise over run, okay? So I'm going to, how far up did I go, or down? But in this case I'm going up, so I'm going up 1 unit and to the right 4 units. So my rise is 1, my run is 4. When you have a positive slope, that's going to be a line that goes uphill from left to right, and a downhill one would be a negative slope, okay? So then there's the 2 pieces I need, and I can write my answer. Y is going to equal 1/4 x minus 2, and there we go, okay? All right, slope-intercept form again for the next question. Okay, so we've got, it goes through this point and it has a slope of -4/3. So if I'm looking at this equation, I already know that this is going to be y equals -4/3 x plus something. I need to figure out what the b is, okay? So now what I'm going to do is plug my xy pair into this. So I'll use this for x and this for y, and let's see what happens. So yeah, I'll put a 0 in here, and a -3 in that slot. Okay, and I should be able to solve this for b. So let's see, over here, a negative times a negative is going to be positive, and then the 3's will cancel each other out, or you could think of that as it's going to be 12 over 3, which would come out to 4. So 0 is going to equal 4 plus b, and then I just subtract 4 from both sides, and there's b. Remember, I already knew it was going to be y equals -4/3 x plus or minus something. Now I know what that something is. Okay, on problems like this, I often see people put the slope in the right place, but then just guess either this x or the y for the b, but that's not going to be the case unless you get super lucky. You need to plug the xy pair in and then solve for b. Okay. All right, moving on. Slope-intercept form again for my final answer here. Okay, this time we've got 2 through points. So I don't know the slope, I have to find it myself. I'm going to use the slope formula. Slope formula is the change in y's over the change in x's. That would give you your rise over your run, because the y's correspond to the rise. X's correspond to run. So I'll have this be my first xy pair, and this be my second xy pair. And let's see, subtracting the y's, I'm going to do -2 minus 5 in the numerator. And I'll do -4 minus -3. Watch out, there's a double negative there in the denominator. Okay? So then that gives me -7 over, that'd be -4 plus 3 would be -1. So my slope is going to be 7, okay? So now, I didn't leave myself much space here. Let me use this space here. I know it's going to be y equals 7x plus or minus something. And just kind of the same way I did on the last problem, I'm going to plug in one of my xy pairs to find b. Which one? It doesn't really matter. You can use either one. I'm going to use this one. So I'll put in 5 for y and -3 for x. But if you use -4, -2 instead, you should have the same answer in the end. Okay, and then I'll add 21 to both sides, so 26 is going to be b. And now I can finish writing this equation because I figured out what the b is. So y is going to equal 7x plus 26. Some of these problems I think I'm going to have to use scratch paper because this is getting pretty crowded. But I'll do what I can right on the page. Okay, so here I've got an absolute value function, which if you graph it, it doesn't ask us to graph this here, but we're going to be doing it later on the worksheet. So we're going to get a v, okay? Sometimes they can open downwards, so it looks like an upside down v, but this one would open upwards because this part's positive. But the vertex, that's the corner, and it's super important. So the way to find it, take the contents of the absolute value and set it equal to 0. Okay, and if you solve that for x, that'll give you the x coordinate of the vertex. Now you could say, well, can't I just change the sign of that? Sure, but if there's a coefficient in front of the x, say I had 4x minus 3, well, the 4 would affect the x value. So I think it's safer just to take that whole thing and set it equal to 0. Your y is just going to be whatever is added or subtracted to the end. So the vertex here is going to be the point, write it like this. The vertex is going to be the point 3, 4. Okay. All right. Next up, is the graph of this function wider or narrower than that of the parent function? So the parent function, which by the way would be this is the simplest possible absolute value function. So that's just going to open up from 0, 0, and it's going to have kind of a slope of 1, going up 1 to the right one, up 1 to the right one, and so forth. Okay, so this one, the 2, is going to affect how wide or narrow it is. So when you have a number more than 1, like I do here, this is going to get narrower. Okay, so my V is going to kind of close from that a little bit. So it'll look like a narrower V. Whereas if I had a number less than 1, like 1/2 or 1/3 or something like that, it would get wider. Okay? All right. Next up, does the 3 represent a horizontal or a vertical change? And so it's going to affect how wide or narrow it is, but it also, because it's a coefficient, but it also, we can tell if there's going to be a horizontal or a vertical change. Okay, so that means, are the points, moving left and right, or are they moving up and down? Either way, it can affect if the V will look wider or narrower. So since we're inside the absolute value with our coefficient here, then it's going to be a horizontal change. The way I remember that is that this is multiplying the x directly. It's not like outside like it is over there. Okay, so it's multiplying the x directly, and the x-axis is the horizontal axis. So hey, horizontal change. This one is going to be horizontal. Okay, as opposed to this one would give you a vertical change because it would be outside. Okay, all right. So let's put these two ideas together on this next problem. So I've got a 1/3, so it doesn't ask me about wider or narrower, but that's going to help me figure this out. So the 1/3, since it's less than 1, this is going to make my V look wider, okay? Which is not a technical term, it's not a mathematical term, but it has to do with these, okay? So then let's look, all right, is this a horizontal or vertical change? So horizontal was when the coefficient's inside, now it's on the outside, not multiplying the x directly. So this is going to be a vertical change. Okay, so hey, I'm going to eliminate those two because I know it's a vertical change. Now the big question, the hardest part of this, is to figure out if it's a vertical compression or stretch. So hey, I know that this is getting wider. So let's say this is the original, the parent graph. If it's getting wider, maybe it'll look something like this. Okay? So there's two ways that I can achieve that though. If my V is getting wider, let me zoom out a little bit. My V is getting wider, I can move the points straight out to the left to get wider. So that would be a horizontal stretch if my points are just moving out. And that'll make it look wider. But it's not a horizontal stretch because I don't have horizontal movement. So the other way to get a wider shape is by compressing those points. Like the ceiling's coming down and smushing this V, and then it's going to look wider, right? So yeah, you could move the points out, but that would be a horizontal stretch. Or a vertical compression. I know it's a vertical compression because if I did a vertical stretch, if these moved up, then it would look like it was narrower. So this is going to be a vertical compression. Okay? That's a difficult concept. I did my best to try to explain it there. Okay, so on to the next page. All right, so I've got some graphing here. So I need to find the vertex. So take the x plus 2, set it equal to 0. And then this is the y, right? So my vertex is going to be -2, -2. Okay, so let's plot that point, -2, -2. The next thing I'm looking for is this opening upwards or downwards? This one's going to open up because everything's positive. Okay, if you look on this next one, I've got a negative coefficient, so that one's actually going to open downward, so heads up, that's because of that negative right there, okay? All right, so the parent graph, I'd go up one to the right one and up one to the left one. So I'm looking, is there going to be a stretch or a compression? Well, there's not, because there's no coefficient in front of the x or in front of the absolute value. So this is going to look just like the parent graph, just with that new vertex. So I'm going to go up one to the right one, up one to the left one, and so forth. And you can make as many of those points as you need, but you get the idea after that, right? It's going to look like that, okay? All right, next one. I know this is opening downwards. Let's find the vertex. So I'm going to find the vertex in the same way. If I set x plus 3 equals 0, then x equals negative 3. And then, hey, there's my y is 2. So it's going to be the point negative 3, 2. Negative 3, 2 is right there. It's opening downwards, okay? So if there were no stretch or compression, I wish I had a pencil here, but if there were no stretch or compression and this was just opening downwards, it would look like this, okay? But there is a stretch or compression, and that's going to come from this. The negative just makes it open upside down. So then I'm thinking 3, would that be wider or narrower? Well, it's a number, and yeah, and it's a little confusing. It's really like the negative just makes it open downwards. But the 3 itself is a number more than 1. This is going to make it narrower. Okay? Just like y equals 3x squared would be a narrow parabola. Okay? So it's going to be narrower. And then I'm thinking, okay, I have this is going to be a vertical change, because if it's horizontal, I'll be in there multiplying the x directly. This is a vertical change. So then vertical change for narrower. Well, let's think about that. If I had these points, vertically I can only move them up or down then, these points. Okay, the vertex is going to stay put. I want this to get narrower. If I move them down, it's going to look wider. So I need to move them up, those points straight up, and then I'll get a narrower looking V. Okay, so this is going to be a vertical stretch. It doesn't actually ask me to identify the transformation, but that's what it is. But now I can look over here and I can say, okay, since that's 3, I'm going to triple the vertical distance these are from the vertex. So looking at this first set of points, it's 1 unit below the vertex. I want to triple that. So sometimes I'll see people go, okay, well, I'll triple that 3, so they count 3 down from here. No, count 3 from here. We want the vertical distance to be 3 from the vertex. Okay, so that's a distance of 3 now from the top of this parabola. And then that second set is 2 units, so I want to triple that. Well, 2 times 3 is 6, so 2, 4, 6 will put me right there. And now these 2 points are 6 units below. So that's my V then is 3 times as tall as it was before, stretched out vertically by a factor of 3 there. Okay? All right, let's try another. So I'm going to find the vertex first. This one's going to open upwards because it doesn't have a negative. Okay, let's find the vertex. So here, it's not just going to be 3 for my x value. I got to take 3x minus 3, that whole quantity, and set that equal to 0. Okay, and then divide by 3. So x is 1, and then my y is also 1 there, right? So the vertex is going to be the point 1, 1. This is going to open upwards. I do have a stretch or compression, which I'll get back to in a sec. But first I'm just going to put like these little points up. I call these the ghost points. Like this was what it would look like without a stretch or compression. So there's my ghost graph. But then I'm going to mess with those blue points. I'm going to move them because of this 3 that I circled. Okay? So the 3 is again going to make this narrower just like it did on the last problem. Okay, and then at this time I've got a horizontal change. Okay, so these blue points can only move left or right horizontally, and I know this is getting narrower, so if I pull them out, it'll look wider. I need to push them together. They're going to move in. Okay, and this is a little hard to visualize, but since this is 3, I'm going to push it in by a factor of 3, which means it's going to get 3 times as narrow. Okay, so if I look at this point, it's 1 unit away from the center of the V. So I want to just have it be a third. So it gets 3 times as close. So I'm kind of eyeballing a third of a unit. And then right here I see that's 2 units, so I want a third of 2. I'm going to take 2 and divide it by 3. Well, a third of 2 is going to be 2/3. So I want that second set of points to be at 2/3, which would line up nicely 2/3 away from the center, right? Which would line up nicely with the first set of points. Okay, if my factor was 2, then I'd end up like right there because it'd be half of 2. But I got a third of 2, which is 2/3. Okay. All right. Moving on, now we have some function notation. So we're going to find f of -3 for this function. So see how I've got the x in right there, and there's the x in the actual equation. So I'm just going to replace that x with -3 and then simplify it. Okay, so I inputted the -3, and I'm going to start inside the absolute value. By the way, you can't distribute into an absolute value function. You can't distribute this too. So I'm going to start with this multiplication. Here, I'll move this way since I'm low on space here. Okay, and then -9 plus 4 would be -5. Sorry, I'm writing so small. Don't have much space. Okay, then the absolute value of -5, that means how far away from 0 on the number line is -5? Well, it'd be 5 units to the left of 0, right? So the absolute value of -5 is going to be 5. And then I've got 10 plus 5, 15. Okay, find f of -3. There it is, it's 15. Okay, here, let me do number 12 up here so I have a little more space. So f of x plus 2, that means my input in here, where the x is, I'm going to replace that with the quantity x plus 2. So I've got 2 times the absolute value of 3 times something plus 4, and then plus 5 after the absolute value. So that something, instead of x, is going to be the quantity x plus 2. Okay, and I'll start simplifying this as much as I can. I'm not going to be able to get all the way to just a number, because it's still going to involve an x in there. But I can distribute right there. And then I can combine the 6 and the 4. And that's all I can do. So a lot of times I'll see people at this point distribute the 2, but you can't do that. These aren't regular parentheses. That's an absolute value symbol, and it doesn't work in the same way. Can't distribute the 2 there. Okay. All right. On the next set of problems, I think I'm going to have to probably use some scratch paper, but I can at least get the setup here. So let's talk about reflecting over the y-axis. So I'm just going to use this graph here to show you an example. So this is the point -5, 1. Okay, if I reflect that over the y-axis, it's going to be over here at 5, 1. Okay, so when I go over the y-axis, the x has changed signs. So reflecting over the y-axis, my new function is going to be, I'm going to take f of -x. So I'm changing the value of the x. Okay, when I go over the x-axis, if I'm going over the x-axis here with the same point, it's going to end up right here at -5, -1. So what's changed signs here? The y has changed signs when I go over the x-axis, okay? And the y is kind of like f of x, okay? So this one, I'm going to do the opposite of f of x. So subtle difference, but it's a big difference. If I'm changing the sign of the x, I'm reflecting over the y-axis. If I'm changing the sign of the y, I'm reflecting over the x-axis, okay? I think I actually might have room to do these two right here, because there's not too much to do. So here I'm just replacing the x with -x. Okay, got it down to that, and then all I can do is rewrite that as negative 3x in there. Yep, got it in. Okay. Our textbook sometimes likes to change the sign of everything inside the absolute value symbol. So this would be equivalent, I don't really care about that, but this would be equivalent to this. So that's another acceptable answer because you can take the opposite of what's in the absolute value function and it'll be the same. It'll have the same absolute value. Okay? So on this one, I'm taking the opposite of f of x. So I'm doing the opposite of f of x. So that means I'm going to take the opposite of all of that. Okay, so negative f of x, taking the opposite of everything that's in the parentheses there. Okay, and then I just want to clean this up a little bit. So I'm going to distribute the negative. I'm going to distribute it right there. You can't distribute the negative inside the absolute value functions. It does not work like that. But I do have this piece out there that's not inside the absolute value. So when I simplify this, I'm going to have a negative 2 out front, 3x plus 4 in the absolute value, and that would be a negative 5. People forget all the time to distribute the negative. So a lot of people will just put a negative in front of the 2 and that's it and call it a day. But no, you're taking the opposite of the whole thing, which means you got to take the opposite of the 5 as well. Okay. All right, next up, going 3 units to the left. So what I'm going to do when I'm going left and right, well, let's look at these. Well, let me go up to the top of the screen for a second. If you look at that, the vertex of this, it's moved left 2 because of this. That's the x value of the vertex. Okay. So when we're moving left and right, we're going to mess with the inside of the function, the x part of the function. So if I want to go to the left, well, look up at that one, right? This sent us to the left when we added 2 to the x value. So if I want to go left 3, I'm going to do this, okay? All right, let's see if I can fit this in. All right, so, okay. So I'm going to input, I'm going to run out of space. So I'll use some scratch paper and then I'll put the final answer on the actual paper. So f of x plus 3, this is for number 15. So I'm inputting this into the function. So where the x is, I'm going to replace it with the quantity x plus 3. Okay, so I'm going to clean this up. So let's distribute that 3 in there. And then I can combine the 9 and the 4. Oh, and I'm off screen. Oops. Now I'm back on. Okay, and there we go. Okay, so I'll write my answer up there, but there's my work for number 15. Okay. And again, you can't distribute that 2 inside the absolute value. You just got to leave it like that. Okay. When you're going up or down, well, you can think about the y-coordinate on the vertices of those graphs. That's going to come from the number that's added or subtracted outside the absolute value. So if I want to go, up 5, I'm going to take f of x and add 5 to it like that. Okay. So here, let's do 16 here. All right, so I'm going to replace that with f of x, which is equivalent to what I have inside the red parentheses there. So I'm going to have all that stuff and then add 5 to it. Okay. Okay, and then when I simplify this, all I can really do is combine those two 5s. Into 10. And there's my solution. Okay, and I'll rewrite that up here for posterity. Okay, there we go. I'm going to take my scratch work off screen. So we can do the next set of problems. Okay, maybe I'll do this. So solve by substitution. Okay. So what I can do here, I want to isolate one of the variables in one of the equations. And hey, the y is already isolated in the second equation. Y is equivalent to the quantity 2x minus 4. So that means in the first equation, I can take the y and replace it with the quantity 2x minus 4. So let's go ahead and do that. And now I've got an equation that only involves one variable, so I can distribute the 3, and I'll be able to solve for x. Okay, I'll combine those into 8x. Now I'll add 12 to both sides. And divide by 8. X is going to equal 1. Okay, now that's part of my answer, but it's not the whole thing. I still have to go back and find the y. So I'm going to go back to one of these original equations. Doesn't matter which one. For me, the second one's way easier to use because the y is already isolated there. And I've just got less to work with. Less smaller numbers, less, well, not smaller numbers, but it's just easier to. So plugging the x in here, and 2 minus 4 is going to be negative 2. So there's the y. So these are both straight lines, and they're going to meet at the point 1, negative 2. That would be their intersection. Okay, let's try 18 out. Now 18, I got to do a little work first. So let me, I want to isolate one of the variables in one of the equations. To me, the easiest one to isolate would be the y in the second equation. Sorry about the bell there. So all I have to do to isolate the y is add 3x to both sides. Okay, now I've got y isolated, so y is equivalent to 7x plus 3. So now I can go to the other equation, the top one. So where I put the box around that y, I'm going to substitute in the quantity 7x plus 3. 2x minus the quantity. Every time you substitute, use parentheses, because that will remind you that you're going to need to distribute. I'm going to have to distribute that negative there. Okay, so now I've only got x's in this equation. I should be able to solve for x. That's a negative 3x there. Okay, let's combine the x terms. That's going to be negative x minus 7 equals negative 6. And then I'll add 7. Okay, if negative x equals 1, then positive x would equal negative 1. You can multiply or divide by negative 1. Okay, and then I need to go back still and find the y that goes with that. So you can actually go to any equation with y and x. So I'm going to go to this one because the y is already isolated. Use that. And so y would equal 7 plus 3 times negative 1. And there's my y value. Okay? All right, so just to get the answers up here, I had 1, negative 2. And you can write it as an ordered pair or just as x equals y equals. Doesn't matter to me. And this one would be negative 1, 4. Okay? Okay, and then moving on to the last problem, which I made a mistake on. That's why I had to edit right there. So I'm redoing it here. So this last problem is the one, it takes the longest for sure. It's the most difficult one on here, I think. So there is a quick, nice way to do these with a graphing calculator. I have another video for that, which I'll put a link for in the description of the video. But I'm going to do this by hand, which is going to take a little while. So I'm going to do this by elimination, like the directions ask. So I've already marked this a little bit from when I messed up the problem. But my basic strategy is I want to pick one of the variables to eliminate. It could be the x, the y, or the z. Here I just decided to go for the y's. But it doesn't really matter which one you go for. Okay, so looking at those, what I want to do is pick a pair of the equations. I've labeled these equations A, B, and C. It's a lot easier to keep track of your work if you label them like that. So I'm going to use A and B first. That's why I have this little squiggly here. So I'm going to use those, and I'm going to try to eliminate the y's. So I want these y's to be opposites. So what I'm thinking is that I can double this second equation because, actually I don't want to just double it because then I'd have negative 2y and negative 2y. But I want to multiply the second equation by negative 2, okay? So over here on my scratch paper, I'm going to need some space here. I'm going to just recopy equation A as it is. I'm not going to do anything to equation A. But equation B, I'm going to multiply everything by negative 2. So I'm going to make myself a little note of that because I want to keep track of what I'm doing in case I have to backtrack or just so I don't forget what I'm doing. Okay, so that would give me, let's see, negative 2 times negative 3x is positive 6x. And then I'd have positive 2y here. I'd have positive 8z. I think it really helps to make the little lines through your z's on these problems so that they don't look like 2's. And then multiply by negative 2 here, that'd be negative 20. Okay. Now if I look at these two equations, if I add them together, if I treat this as a big addition problem, those y's are going to cancel out, and that's what I want to happen. They're going to eliminate. That's why this is called elimination method. Okay, so for the x's, 3x plus 6x is 9x. For the z's, 1z plus 8z is 9z. And then let's see, I've got negative 27 when I add those negatives together. Okay, now I've got a new equation, but this equation only has an x and a z, no y's. Okay, I'm going to give this new equation a name. I'm going to call this equation D, because I've already used up A, B, and C, okay? And I'm going to put that aside for a minute, and I'm going to repeat the process, but I want to use two different pairs of equations. So I'm going to use B and C here. So I could have used A and C as well, but I want to eliminate the y's again. So I'm reminding myself here, okay, I eliminated the y's, so I'm picking a different pair of equations, but I'm going to eliminate the same variable, okay? So using B and C, and let's see what we'd have to do to get those. Well, I might want to get it to say 3y and negative 3y. So I'm going to multiply the top equation by negative 3 because I can't just multiply that one piece by negative 3. I've got to do it to the whole equation. Okay? The equation C I'm going to just leave alone. So let's see. I'm going to carefully multiply equation B by negative 3 each part. So that would be, let's see, 9x plus 3y plus 12z equals negative 30. Okay, I'm just double checking my work here. Okay, good. So the problem with this method, one little mistake on a sign or multiplication, it's going to throw everything off, and you'd never really know it, maybe until you get to the end. Okay, and then equation C, copying this down carefully. Okay, and now when I add these together, again, the y's are going to cancel. So let's see, I'll have 13x plus 15z is going to equal negative 37. So I've got another beautiful new equation. I'll name this equation E. Okay, now what I've done, I've created these two equations that only have two variables. So I'm going to use those together. Okay, so I'm going to create a new system of equations using D and E. And you could use substitution here, but I'm going to stick with elimination since I'm already going down that path. So I'm looking at the x's. I've got 9 and 13. Well, those don't work together great. And then I've got 9 and 15. Those don't work together great either. I think I'm going to eliminate the, let's see. I'll try to eliminate the z's here. I'm just thinking, well, 9 and 15, at least 3 goes into both of those. So let's see, I can find something that 9 and 15 go into. They both go into 45. So if I took this top equation and multiplied it by 5, I'd have a 45z. And then if I wanted to get a negative 45z, I'm going to multiply by negative 3 down here. So I'm going to have to multiply both equations. Okay? And then equation D here, let's see. Let's multiply everything by 5. I'd have 45x plus 45z is going to equal 5 times negative 27 is negative 135. Okay? And then carefully I'm going to multiply this equation by negative 3. Let's see, negative 39x minus 45z, and then negative 3 times negative 37 is going to be 111. Okay? So now I'm going to add these together, and then I should be able to solve for x because these z's are just going to cancel out there, right? So let's see what I have left. I'm going to have 6x equals, this is going to come out to negative 24. And hey, I just have to divide by 6 then. So x would equal negative 4. Okay, so I've got one of my variables, but I still need the y and the z. So what I'm going to do is go back to an equation. I don't actually want to go back to the original equations right now. I want to go to an equation that has just an x and a z in it. So either equation D or E, and it doesn't really matter which one. So I'm going to choose equation D, and I'm going to plug in this x value. So 9 times negative 4 plus 9z is going to equal negative 27. Whoops, I'm off screen, sorry. Plug in just the x value I already knew into equation D there, okay? And now I can solve for z as well. So let's see, negative 36 plus 9z equals negative 27. Okay, I'll add 36 to both sides. And I've got 9z is going to equal 9, which means z would equal 1. Okay, now that I've got two of the three variables, now I'm going to go back to one of the equations that has all three variables. I still need to find the y, so I got to pick an equation that has a y in it as well. So maybe I'll just go to equation A all the way back to the beginning to equation A. I don't know, or I do know the x. The x was negative 4. I don't know the y, but I know the z is 1. Okay, and then I can solve for y here. So let's see. Okay, I'll combine the negative 12 and the positive 1. Then I'll add 11. Almost off screen. Let me zoom out a little bit. Okay. And then divide by negative 2. And y will equal negative 2. And off screen one last time. There we go. Okay. And now I have my x, my y, and my z. So you can write your answer like this. You could also write this as an ordered triple, kind of like an ordered pair. It's just there's 3 numbers. So the x would go first, then the y, and then, whoops, 4, negative 2, and then the z is 1. So used to doing the ordered pair, I just closed it off after the second one. But yeah, you could also write that like that. Either way is fine. You don't need to put it into a triple. But that means the same thing. And that's it for the review. And I'll see you next time.